Hi, Math 3. Welcome to your 3.6 Ed Puzzle. So let's start off with the essentially definition of a polynomial. All right. So it says a polynomial function has the form, and you can look at it. It's like a sub n of x to the power of n plus a sub n minus 1 times x to the power of n minus 1, and so on until you get down to this guy here, which would be a constant. Basically, what this is showing here is it's x values saying, and this n is telling you it can be any number, so you could start off with any positive value here. So it could be like a 5, and essentially what they're saying is you can go down to a constant, which would be this a sub 0. So you could have like 5 plus 6. You could have terms in between there, right? You could have like plus x to the 8th, plus x to the 4th, plus 10. So a polynomial is just when you have terms being added together, and these terms are being raised to a whole number. I should say whole positive number. So it says where a sub n minus 1, a sub 1, a sub 0 are real numbers, and n is a non-negative integer. This is important. All right, that power needs to be a non-negative integer. So if that power is a negative integer, or something that's not an integer, that is not going to be a polynomial. In other words, a polynomial is the sum of one or more monomials with real coefficients and non-negative integer exponents. The degree of the polynomial function is the highest value for which n where a sub n is not equal to 0. So what they mean by that is you always look at the highest power. So for example, let's say we had x to the power of 5 plus x to the power of 3 plus 0. Or 0, that's weird. We'll do plus 2. The degree is going to be the highest power, which would be 5. All right, so this would be a degree 5 polynomial, or a polynomial of degree 5. Now, the highest power may not come first. You might have something like 3 plus x to the 8th plus x to the 10th plus 80. All right. Of course, you're still just looking at the power, so this would be a degree 10. Now, also the coefficients don't play a role, right? You could put like 3, 5, and 2 here. That's not going to change. This is still a degree 10 polynomial. All you're doing is looking at the highest power. All right. So now it says the following examples are examples and non-examples that will help you see the important implications of the definition of a polynomial function. For each pair, determine what is different between the example of a polynomial and the non-example that is not a polynomial. All right, so this first guy here is a polynomial. This other guy is not a polynomial here. So we've got x cubed and 3 to the power of x. So how are a and b different? Well, this b here, this is an exponential function. That's what I would say. I would say b is exponential. And how do you know that? Well, the variable is in the power, or in the exponent, I should say. The variable is in the exponent. All right. Then we've got c and d. All right, so c is a polynomial. You can see that you have x being raised to a power. We've got no negative powers, no issues there. But d is not a polynomial. So what makes d not a polynomial? Because you have stuff in the denominator. All right. Polynomials need to have a denominator of 1, right? You can make anything a fraction, but essentially they need to have a denominator of 1. So how are c and d different? You could just say like d is a fraction, right? And it does not have a denominator of 1. All right. Now we're looking at e and G. I'm sorry, E and F. Goodness gracious. So for E, that is still a polynomial, even though it has a negative sign. You can have negatives, right? You can have different coefficients, but the powers still need to be positive whole integers, all right? Positive whole numbers there. Now, at first glance, F looks good. You're like, oh, well, it looks pretty good there, right? We got some good powers checking out. But here is your problem. All right. Based on the definition, they need to, n, which is the power, needs to be a non-negative integer. So you could say f has a negative power. And you know, one thing I should real quick check, I didn't really go over this. Let's talk about the degrees of these. So for A here, this would be a degree 3. All right. For C, this would be a degree 2 because the highest power is a square. For E, that is also going to be a degree 3 because the highest power is a 3. All right. If we look at H, that's going to be a first degree or degree 1 because this essentially has a, imaginary 1 there. So for this one, it asks how are H and I different. So if you look at I, X is in the denominator. We can't have that, okay? All right. And then for J and K, first off, J is going to be a second degree polynomial. And if you look, the power here is not an integer, right? That's a fraction, which is not an integer. So you could say the exponent in K is not an integer. All right. Cool. So now let's go ahead and move on. It says find the solutions to the following functions. All right. So first off, let's talk about what solutions are. Okay. Solutions are essentially the X value when Y equals 0. Okay. Another way you could think about it is it's the x-intercept. Okay. So if we're looking here, we could look and say, okay, well, the solution here, the x-intercept is -2. That's one way to find the solution. Now, another way is to actually use the equation. Let's say we weren't given the graph. How would I find the solution to this function? Well, I would set it equal to 0. All right, and then solve. I get x equals -2. All right, so that's 2 ways to get the answer there. All right, now let's go ahead. For example 2, let's do the solving method first. Let's see if we can find this by solving. So we're going to go ahead and we're going to factor this. Well, I guess first we'll set it equal to 0, and then we'll factor. So when you've got a trinomial like this with no greatest common factor, you're going to want to go ahead and do that thing where you try to see what multiplies to give you a 6 and adds to give you a -5. So that's going to end up being x, and it's going to be -2 and -3. So then you set each of those equal to 0. So you get x equals 2 and x equals 3. So that's how you do it by solving. And then if we are lucky enough to have a graph, well, perfect. We got 2 and 3 as our solutions. All right. Now, for the last part here, it says write the conjugate of the given value. So first off, what are they talking about? So if you look down here at the Go, it gives this long explanation to what a conjugate pair is. So basically, the takeaway is that a conjugate pair is simply a pair of binomials that have the same numbers but differ by having opposite signs between them. For example, a plus b and a minus b. So when you're trying to find the conjugate, all you need to do is change the sign, okay? So if you look here, the conjugate of 8 minus 6i is just going to be, 8 plus 6i. That would be your conjugate. Then here, while this is only one term, could be written as 0 minus 6 root 5, right? So the conjugate here would be 6 root 5, positive 6 root 5. All right?